Right, here is chapter 6.1 homework help. For question number 3, we're going to get into it right away. I've got this distributing going on, right? This is just order of operations kind of work here. We've got 2 times 3p, which is 6p. 2 times negative 6 is negative 12, right? Or 2 times 6, but then add a minus sign in there. And then we're just going to stick this 4p on the end. Combining like terms, 6p and 4p, that's a total of 10p, and then I just have this minus 12 on there as well. And that'll be my simplified expression. For this one, remember when we distribute, if there's a negative out front, I need to distribute that to all parts. Right, negative 3 times 4n is going to be negative 12n. Negative 3 times 1 is negative 3. From there, these two can combine with each other, except they don't like each other in the fact that 5n is positive, 12n is negative, 12n is bigger, so this is going to stay negative, negative 7n, and then we just tack the minus 3 on the end. For number 5, what is the solution to 2n minus 4 is greater than negative 12? Well, I've got 2n minus 4 being greater than negative 12. First step here, we would add 4 to both of these. I have 2n, and then negative 12 plus 4 is negative 8. Finally here, I'm going to divide by 2 on each of these. I get n being greater than negative 4, which is option D. Alright, here's a whole bunch of converting between percents and decimals, or decimals and percents. Right? So if we see a percent sign right away, we probably should end up at a decimal. If we don't see a percent sign, we're going to want to in our answer. So here I'm starting at a percent. Again, we cross out the percent sign. Our decimal point moves 2 to the left, and I get 0.26. For 9%, move the decimal twice. There's this imaginary number here. Right? We have to fill it in with a 0. I get 0.09. It is not 0.9, that would be 90%. All right, get rid of the percent sign. I don't need to add a decimal, right? There's already one for me, 1, 2. This becomes 0.447. Number 14, get rid of the percent sign, start at the decimal, go 2 to the left. My repeating bar still stays in here, but it only goes over the 2. Okay, it doesn't just automatically go to the 3 and 9. Those two we're not repeating. All right, now I've kind of got a decimal. There's no percent sign to work with. So instead of going to the left, I'm going to go 2 to the right. Before the decimal, I have 355. After, I've got 4. And I add a percent sign. 16, we're kind of back to before. Get rid of the percent sign, add my decimal. 2 to the left, I get 1.23. 17, there's no percent sign, so I need to go 2 to the right. 4 comes before the decimal, 1 comes after, add my percent. Finally, number 18, no percent sign, I'm going to go 2 to the right. 12 before the decimal, 2 after, with a percent sign. All right, writing fractions as decimals and percents. This is where we have our fraction, and we think, is there an easy way to get to 100 first? For this one, there is a nice way to get to 100. 4 times 25 would get me there. So if I do it on top, right, this is 3 times 25, which is 75. Once I get a fraction over 100, in our notes we talked about how that is actually our percentage, whatever our numerator is. Right, and then afterwards I can convert that to a decimal, get rid of the percent sign, move 2 to the left. I get 0.75. For the next one, I don't have an easy way of getting to 100. Nothing times 3 is going to get me there. So instead, we're going to divide these two. 3 does not go into 2, but it does go into 26 times. 6 times 3 is 18. If I subtract there, I get a 2. All right, add a 0, drop it down. Well, 3 goes into 26 times, like last time, and I get a 2 again. And no matter how many times I drop a 0, right, I'm still just going to get this repeating pattern of 6s. So I can comfortably say that my decimal is this 0.6 repeating. However, now I need to change that to a percent. Repeating decimals, changing to percents are always difficult, right? We have to think about this decimal being something like this. Move my decimal twice to the right. Before the decimal point is 66. Afterwards is still 6 repeating, right? It doesn't stop. And now I can throw my percent sign in there. All right, so here's my decimal. Here's my percent. 26, this is a nice way to get to 100. 5 times 20 gets me there. So on top, I'm going to do 12 times 20. 12 times 20 ends up being 240. Again, with a fraction as 100 on the bottom, my numerator becomes my percentage. To make this a decimal, I get rid of the percent sign, move 2 spaces to the left, and I get a decimal of 2.4. Calculated it before, it's right there. It's 0.6. Here we got 3 left to go. This is a little interesting way you could do it. We can show the other way too, but there is a way I could get to 100 from 1,000, and it's actually by dividing by 10, right? So then on top, 1 divided by 10 is 0.1. If I do that in my calculator, that actually becomes my percentage right there, 0.1%. Now this would have worked out the exact same if I divided, right? Put 1 inside 0. The 1,000 doesn't go into 10, 1,000 doesn't go into 100, but it does go into 1,000 once. And I end up at 0. So my decimal is 0.001, and if I were to move it over twice, we can see that my percentage is correct right there. So again, multiple ways to do it. If you can get to 100 on the bottom, I suggest getting there. It makes it a lot easier. 3 over 11. This is not going to be an easy one, so we're just going to divide right away. 3 doesn't go in, or 11 doesn't go into 3. It does go into 30 though twice. And I get an 8. I'm going to add a 0, drop it down. 11 goes into 87 times. When we subtract, I get a 3. Drop down a 0, and I get to 30 again. So here we can see I'm probably going to get a repeating pattern again. This is a 2, right? And here is a 7, and I end up back at 3 again. So comfortably I can say this is a repeating pattern. I get the same thing happening each time. Notice though it's both of them. It's not just 7 or it's not just 2. It's actually both of them that repeat like that. So this would read 0.272727. To make this a percentage, I'm going to kind of write it out again. Right, 272727 dot dot dot. We're going to move it twice to the left, or twice to the right. Before the decimal now is 27. Afterwards is still my 27 repeating. Right, repeating decimals never go away, even in percentages. And there we have it. Here's my decimal. There's my percentage. Lastly, number 32. We're going to divide 9 by 22. All right, 9 goes into 2 0 times, but does go into 22 twice. And I end up at 4. Add a 0 and a decimal. 9 can go into 40, not 6 times, 4 times. 36, and I end up at 4. And quickly here we can see we're just going to get a repeating pattern again. All right, so my 4 is what's repeating. My decimal then is 2.4 repeating. I'm going to write this out a little bit to get my percentage. Move it twice. Before the decimal is 244. After the decimal is 4 repeating. And we have our percentage. Okay. Last two here. Number 33 says order the numbers least to greatest. For this one, right, ordering is the easiest way is to convert all of them to the same form. For me personally, it's decimals for sure for me. So 66.1%, right, is going to change to 0.661. This is going to stay the exact same, 0.66. 2/3, 0.6 repeating. And then this is already a decimal, so I can just leave it alone. Okay? Now, from here, we need to make sure that all of them have the same amount of decimal places afterwards so we can compare. Right? This one has 3, this has 2, this only really has 1 right now, but we know it's infinite, and this has 3. I'm going to make sure all of them have 3. This doesn't need to change. This one does, since it only has 2, and since there's nothing afterwards, I can just put a placeholder 0. 0.6 repeating, well, that's just going to be 0.666 and continuing onwards. And then here, we've got 0.667, that already had 3 after. Now it is nice and easy to compare these, right? Comparing the ones digits, they all have zeros. The tenths digits, they all have 6s. Hundredths digits, they all have 6s again. And then the thousandths digits is where it gets a little different, right? My least is 0, so I know that one's going to come first. And again, when we order, we put it back into the original form. Okay, so this one's all good. The next one, lowest, was with a 1, which went with 66.1%. Then out of these two, 6 is smaller than 7, so we're going to write 2/3 next. And then finally we have 0.667. All right, and right there is going to be my answer. All right, the table shows the portion of students in each grade that participate in School Spirit Week. Order the grades by portion of participation from least to greatest. Again, we're going to change all these to the same form. I'm going to stick with decimals. If you want to choose a different form, by all means go for it. All right? This is already a decimal. 3 divided by 5, right? 3 inside, 5 outside. 3 doesn't go in there, but it does go in 6 times right here. And it does so evenly. 0.6. 65% converted to a decimal is 0.65. Both the top and bottom have 2 decimal places afterwards. The middle only has 1. However, we know, right, the next number would have been a 0, so we can just fill that in. Now we just have to look at these decimals and say, hey, which one is the biggest, which one's the smallest, which one's the middle, and then we can order them least to greatest. They all have zeros in the ones column, all have 6s in the tenths place. In the hundredths place, that's where we have different numbers, and we can see that the lowest was grade 7. The next lowest was grade 6, and the highest was grade 8. And just like that, we've ordered them by grade. All right, that is all for 6.1 homework help.